Okay, transistor logic. Transistor logic. As I said, is a very important question. So TTL stands for transistor logic. It is a type of digital logic used in daily electronic circuits like computers, industrial controllers, and consumer electronics. And all your whatever washing machine, whatever you use, consumer electronics. Everywhere, transistor logic is very widely used. That is why it's a very important question. So why transistor logic? Because transistor can do two jobs. They perform the logic like AND or NOT, etc. And also they can amplify the signals. Both they can do. They can work as a Boolean function as well as they will amplify the signal. Because transistor acts as an amplifier, right? Because of the advantage of transistors, we are using that thing. So what is inside a NAND gate? In a NAND gate, we will use one symbol like this, right? NAND gate. So what is inside this? This circuit is inside. Okay? This circuit, whatever it is, that is inside that. That is a symbol. But inside we have this. So we will have 4 transistors. Resistors, diodes, power supply. So these are all, this consists of, the NAND gate consists of this. See, one more thing which you have to see is the output transistors Q3 and Q4 are arranged. Essentially, they are called as total pole. This will help you to give strong output signal to Q3, whether 0 or 1. So that is totem pole means one transistor sitting on the other transistor. Okay? T1, T2. Here we will take it. Whether it will connect 0 VCC to output or it will connect ground to in a faster manner. That is why this arrangement is called as quantum pole. Quantum pole. That is how it is constructed. So this is what is the circuit diagram of this 2 into TTL NAND gate. Very important question. So you have Q1, Q2, Q3, Q4, 4 transistors. 4 transistors NPN. So you have this emitter here, base here, collector. Emitter, base, collector, base, collector, emitter. Collector is collector. Case 1. You see, case 1. Our truth table is A, B, and NAND. What is the output here? What is the output here? Right? So our circuit should produce this. First condition 0 0. Taking the first condition 0 0. A equal to 0, B equal to 0. Both inputs are 1. So here you have a diode combination. Emitter, yes. When diodes are connected back to back, it is a transistor. You know that? Diodes are connected back to back, it is a transistor. That is how they are formed. Because a diode will have a PN junction. So in an NPN transistor, what you have? Here one PN junction, here one PN junction. So diodes connected back to back will produce a transistor. So here you have this portion we call it as a diode junction. Okay, they are 0 0. That means here what is it? N, P, N transistor. So N is connected to low, means it is forward bias to reverse. N connected to low or zero. Forward bias to reverse. N. This is your transistor. It is a 2-input transistor. P, N, N. I am connecting this N to low. Forward bias or reverse bias? Forward. So this junction, this side is forward bias. So there is connectivity. Whereas here it is open. This side is open because N, P, N is connected to P. So reverse bias is open. Now the diodes VA, DB are on. VA, are here, A and B. VA, are on, so forward bias. Current flows through the resistors and diodes. Q2 does not turn on. This is not turning on, but this is turning on. Any doubt in this? Okay. Since Q2 is off, Q4 is also off. Because how the current will not flow? Q2 should only supply the current through the emitter to the base of Q2. The current should flow from here to here. From here to here. Since there is no flow of current, this is also off. So what happens now? Now the Q3 pulls output to 5. So only this connection is there. Plus Q3 gets the forward bias from here. So the output is 5 volts. The output is this is on, this is off, this is off. So the output is 10. Or A equal to 0, B equal to 0, A dot B, A dot B the whole bar. So what will be A dot B? 0. Now coming to 0, 1. So in 0, 1 condition what happens? A equal to 0, B equal to 1. One input is low and one input is high. So the diode with the low input is still on. Diode with the low input is still on. 0, 0, 1. So if you consider VA, DB, this is on, VA is on, it's forward bias. So what happens? Q2 stays off again. Then Q4 stays off. Again, there will be a flow from VCC to output. High. High or low? High. Then the next condition, we have A equal to 1, B equal to 1. Because even when the third condition A equal to 0, B equal to 1, A equal to 1 and B equal to 1, until any one is 0, that diode is going to continue. A is 0, B is 1 also, this is going to continue. A is 0, 0 also, this is going to continue. 0, 1 also, this is going to continue. 1, 0 also, this is going to continue. 1, 1, what will happen? This will not continue. 1, 1 condition, this is not going to continue. So now what happens? Diode DC turns on, allowing current to. So this side, the current flows to this. So this will be on. This will be on. So what happens? Short circuit into ground and now it is moving. So only for 1, 1 condition, the output is going to be low. So this acts as a NAND gate. So here you can see these 4 conditions. Here both the inputs are low, the output is 1. Both the inputs are low, the output is 1. If any input is 0, the output is going to be 0. So these 4 conditions you have to write and explain which transistor will be on for each condition and say what will be the output. So NAND gate. This is what is happening. Why PTL means? PTL is fast switching, strong signal because of their monopole and easy to use in logic circuits. So these 4 transistors, you have to remember how it works. When you have 0, 0, this will be on, this will be off, this will be off, so output will be high. When you have 0, 1, again this will be on, this will be off, this will be off, output will be high. When you have 1, 0, again this will be on, this will be off, this will be off, and you have output high. And then finally, you have 1, 1, what happens? This will be off, this will be on, this will be on, and this is connected to ground, and output will be low. So this you have to remember and you know the truth. With that you have to explain. You have to remember this circuit. Practice. First you prepare this. Surely you will come. Truth theory. You have to draw and then that transistor circuit. And also you can have a table. A, B, 0, 0. Q1, Q2, Q3, Q4, output. 0, 1, 1, 0. So what is the output here? High, 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 low. So then we can write which transistor is on and off on each connection. So that will also give you a support to your answer. Okay? 0, 0. Set that is 0, 0. Q1 is on. Q2 is off, Q3 is on. Like that, then in the table it will give you more value to the values. Okay? So that is what is explained here, transistor logic. Then output configuration of ATL. The output, we are seeing total mode output. There is also called as open collector output and tri-state gate output. There are three types you can give the output. So total mode output. The circuit shown what is the shaded portion shows the total mode output. That is this portion, the dotted line. That is the total mode. One transistor sitting on the other transistor. The transistor Q3, Q4, diode D and the current limiting resistor form total mode output configuration of ATL. There are few advantages of using this configuration. What are the advantages? When the output switches from low to high, output goes from low to high. The output transistor Q4 goes from saturation to cutoff. During this transition, the load capacitance across Q3 charges exponentially from low to high voltage. There is a diode here. So this is what is the totem pole output. In PTL circuits, the totem pole output is a special way of connecting two transistors Q3 and Q4. At the output side of the gate. Think of it like a teamwork setup where one transistor pulls the output up and other transistor pulls it down. And the diode and resistor help manage the current flow slowly. So this way, this transistor will be to high, this transistor will go to low. Quickly, okay? Then what is inside the total pole? They ask separately about total pole. What do you have in the total pole? You have Q3, you have Q4. This will pull to high. This will move to low. And you have a diode and a transistor. The diode will prevent both from turning on. It will not allow both the transistors to turn on. The resistor will control how much current to flow safely. So this is what is the construction of totem pole. We have two transistors, one transistor sitting on the other transistor. The top transistor will connect to high, the bottom transistor will connect to low, and the diode is used so that both the transistors are not turned on simultaneously, and the resistor will limit the current. That's all. Okay? This question also very, very important. So when the output should be low, Q4 turns on, bringing the output voltage to 0. So here you have two transistors, a diode, and a resistor to be 260. So Q4, this is Q3, this is Q4. Q4 turns on, this is connected to load. Q3 is off. When Q3 turns on, Q4 is off. This is connected to VCC is connected to. Only one transistor is on at a time because of the diode was there. Diode is there to take care that only one transistor will be on at a time. Because it helps the output and change fast and handle more current, they are using totem mode. Why we are using totem mode is because it is faster and also handle more current. So these are the two advantages. Open collector. here you don't have one more transistor. You have only one transistor. Only one transistor. In total mode you have two, here only one. So the open collector configuration, the output does not directly connect to the voltage inside the chip. Instead, it leaves the output transistor collector open. Here this is emitter, this is collector, this is open. And you need to connect to an external pull-up resistor. This is an external pull-up resistor to make it work. Okay, in the chip, there won't be any connection. You have to connect externally the resistor, acting as a pull-up resistor. That is one constriction. So the output wire will be hanging. You must attach it to the power. It will be hanging, nothing. You have to connect through the resistor to VCC like this. How does it work? Imagine a switch connected to ground. Transistor Q4 is like that switch. It is like this switch connected to ground. Case 1, transistor Q4 is off. What will happen? Off means Q4 is open. The output is not connected to ground. Isn't it? So this is not connected, means not like that. Open, right? When this is not functioning, it's open. So when the switch is open, transistor Q4 is off and the switch is open. The current flows through the pull-up resistor and the output is set. So from there, you get high. Next one, when the transistor Q4 is on, Q4 is on. What will happen? When Q4 is on, the switch is closed and the output is connected to the ground. This is connected because Q4 is on. So output will be connected to the ground. Short circuit is more dominant over the one connected with the resistor because the resistor will stop the current flow, isn't it? Here you have the resistor which will stop the current flow, but here it is short circuit. So that will be coming here as output. So what you need to remember is transistor Q4 is off, output is high because it is connected to the VCC. Okay? Now, first condition is what? I am considering this is off. So when this is off, what will be the circuit? So what will be the output? Right. When this is on, this is on. What will happen? Okay, this is sure. Why we are using open collector? Multiple devices can share one wire. You can connect many outputs together safely. Great for alarms, indicators, these are all examples. They will ask you why open collector is useful and where it is useful. You can connect many outputs together there safely and it's used for alarms, indicators or communication aids. And it can control high voltage. You can use a pull-up to higher voltages than chip uses similarly. Sometimes on is only inside the chip. But here there will be some pins from the transistor. Okay, this is Q4. From here, I will connect to the resistance externally, outside the chip. So here I can decide what sort of resistor I need to connect. What should be the value of this resistance? So I can control high voltage. V equal to IR. If R is high, I can control the voltage, high voltage. Then flexible output control. So you decide what voltage the output should do. What should be the drop across this resistor? There will be a current output and V equal to IR. So based on the resistor value, you can decide what output you need. How much drop should happen in the resistor, how much should come out. VCC minus IR is what is going to come out, right? VCC minus the drop is only going to come out. If you want lesser drop, resistor will be less value. If you want more drop, resistor will be higher. So externally we have, it is not inside the chip. If it is inside the chip, you cannot change. Here it is outside. You yourself can decide. So that is why it is the advantage. So imagine one analogy is given. Imagine a rope hanging freely. You must tie it up to a pole using a rubber band. When the switch pulls the rope down, the output is low. When the switch let go, the rubber band pulls it back and output becomes high. Just imagine that. So next is tri-state output. Tri-state, 3 states. High, low, it is something like disconnected, high impedance. So tri-state is shown here. Why tri-state? Why 3 states? Most logic outputs have only 2 states, high and low. But in tri-state there is a third special state. High impedance state. It's like the output is disconnected from the circuit. It does not interfere with the rest of the system, but this is useful when multiple devices share one line, like data, buses and the computers. There will be situations where you need such an output, so we are using this tri-state. How it works? Inside the circuit, 2 transistors control the output. Q3 is on. Let us see the circuit first. This is the tri-state. Q3, Q4. This also has a photopolar. So what happens? Q3 is on, output is high, Q4 is on, output is low. Similar to when Q3 is on, what happens? Output is high. When Q4 is on, output is low. Both are off. This condition only we are going to get this tri-state, which is output is high impedance state. It will be like a disconnected. So Q3, Q4. So why this is useful? Where will you be using this? This is great for systems where multiple devices talk on the same wire. Computer data buses, you will be having number of data lines. So multiple devices will be having interaction of signals, giving out like that. microcontroller output is shared communication lines. So they can make certain connections hold by this high impedance. It is something like non-connector. So each device can take turns controlling the line, and when not in use, goes into high impedance state so that it will not interfere. It will not interfere. Okay? So very few conditions, especially in multiple devices where they are interacting, you will get that. So these are all something which we have seen. Proton hole, open collector, dry state. The advantages of dry state is high speed operation, ETL and RTL logic devices they are used, less power dissipation, low cost, better turnout, and reliable operation for noise. These are all about dry state, gauge,